I'm seeing, okay, guys, don't forget, write down the number of electrons. So Cl2O. I was seeing a lot, I was seeing a lot of this. Okay, I'm seeing a lot of that. Okay? We've used all the electrons, but there's something wrong about this.
Chlorine has too many electrons?
Chlorine has too many electrons, but also combining capacities. You've got to use your combining capacities. Chlorine has a combining capacity of 1. Oxygen has a combining capacity of 2. Chlorine here combined twice, oxygen 4 times. You've got to remember to use that. So it would be O, Cl, 2, 4, 6, 2, 4, 6, 2, 4. It would be bent, but if you drew it like this, that would be fine. But you are correct. It actually goes down like that. Yep, they take up, lone pairs of electrons take up more space. But if you wrote this, I would give you your marks. Okay? All right. CH3OH. How many got a structure for this one? Not asking if it's the correct structure, just asking how many got this, how many people got this far? Good. Okay. The good thing about compounds is that generally the order of the atoms is basically how they're joined together. So CH3OH. So you definitely have an H attached to an O. And you've got your carbon that can make 4 bonds. So it's this O is going to be attached to the carbon as well as those 3 H's. So carbon brings 4. Hydrogens bring 4. Oxygen brings 6. So we've got a total of 14. Carbon makes 4 bonds. Put on your 3 H's. CH3, then your O, and then your H. How many have we used?
10.
Okay, how many more do we have to place?
4.
How many people got it? Well done. And don't worry about it if you didn't, because you're going to get there. Okay? So, often it's horrible if I give you just the number of carbons, the number of H's, and the number of O's, because there's so many different combinations that it's hard to get the correct structure. So you will be given them in this order. Did anybody get a structure for the last one yet? Yeah. Oh, you think you did? Wow. I'm impressed. You don't know if it's right.
Listen, it's an easy fix though. But look how many carbons, look how many electrons carbon has. Look how many electrons.
Okay, it actually looks like that.
Yeah, mine's definitely.
Okay, I'm going to give you, before anybody else tries it, I'm going to give you the other strategy, which helps. Okay, I'm going to give you another strategy that helps. So TVS, total electrons wanted. Total electrons wanted
Where's the E?
is the T, total. V, the number of valence electrons. S, the number of shared electrons. So total, don't write this down yet. I'll give you time. Total one. Psst. Do you want me to take that pencil from you? Now, how many electrons are in a bond? 2. So if we figure out how many are shared and we divide by 2, that gives us the number of actual bonds in the structure. So if your structure has 4 bonds, but it says there should be 5 bonds, you know to make a double bond somewhere. It's going to help you. So, total electrons wanted. We're going to do methanol again. CH3OH. I'm going to do it with you, then you're going to copy it down, and then you're going to try it with another structure before we do the last one. So T. How many does carbon want to be surrounded by in total? But how many electrons? 8. Carbon wants 8. How many does hydrogen want around it total? 2. How many hydrogens do we have?
4.
So we want a total of 8. Right? 4 times 2. How many does oxygen want around it?
8.
How many total do we want?
24.
24. All right. Let's go back to the number of valence electrons. How many does carbon bring? 4. How many does each hydrogen bring? 1, and there's 4 of them for 4. How many does oxygen bring?
6.
Okay, for a total of?
14.
Okay. Shared is the difference between these two numbers. So how many shared are there?
10.
Divide that by 2.
5.
We need 5 bonds. Okay, so if we put our carbon on, we know it's going to make 4, so there has to be another bond somewhere else. So if we put in our H's, if we put the O down, we know the other bond has to be on the other side. There's our structure. How many electrons have we used? 10. Subtract that from the number of valence electrons. How many do we still have left to place? There you go. You can use either method. I don't have a preference. It's going to be what works best for you. So copy this down, and when you're done, I would like you to use TVS to figure out the structure for HCN, hydrogen cyanide.